Alright, so the other three basic tastes we talked about. So we covered salty and sour. What about sweet, bitter, and umami? Well, sweet, bitter, and umami, what we have here are G protein receptor coupled receptors. Again, if you haven't had a molecular biology class, but again, for this class, just know that these are protein receptors. Yeah, so again, it only works if there's water. So yeah, because the thing is that you need those ions to reach the actual proteins or where it substrates it needs to act on for it to cause its effect. Now, bleach is different though. That's, if you're talking about how it works on clothes, that is not so much receptors but a chemical reaction. Alright, so then what we have here with sweet, bitter, or umami is that we have the inactive G proteins, but what's happening is that these, if it's a sweet receptor, a thing like a monosaccharide, a carbohydrate is going to activate those receptors. Yes, these are chemical ligand binding. Yes, because you have a ligand, this is a chemical, it can be either sweet, bitter, umami, binding to a membrane protein receptor, and this causes some sort of this causes activation of G proteins at this level. Just know it activates kind of like a chain reaction or like a domino effect of all of these intracellular enzymes and chemical reactions. So you have all these intracellular chemical reactions, and this causes a bunch of chemistry inside the cells. And what it does is, with all these things we call second messengers, just know a bunch of chemistry happens when you have these ligands binding to the receptors, and then this leads to the release of neurotransmitters. So that's what we have there. Alright, so then sour, sweet, salty, bitter, and umami. And then water is debated, don't have to worry about for this class. Actually, I know oleogustus, like oleo refers to fat. It's just literally fatty taste. Like, I know like my better half likes likes rich stuff. I like things that are sweet. And it kind of makes sense because umami is linked to L-glutamate, an amino acid. So it's kind of interesting. So you have both like carbs, you have proteins, and you have fats now represented. And I think it's almost canon. Like fatty taste is almost, they found receptors for it. I think it might be, if it's not already canon, it's close to becoming canon in terms of basic taste. So there might be 6 basic tastes. So the tongue map is a myth, but now we're finding out that there are more different tastes. Yeah, so monosodium glutamate, this is why they added 2 flavors, because why? Umami is glutamate. Glutamate is amino acid, and a lot of things that have this amino acid lend to that sense of umami. And spicy. Now, is spicy a basic taste sensation? Spicy, we know things taste spicy, but believe it or not, spicy is not a basic taste sensation. And why do they not classify as a basic taste sensation? The interesting thing is that there are protein receptors for the chemicals that cause spice, but this is why not. So spiciness, things like chili peppers or this really delicious looking kimchi, well, what causes that? So it is behind it, there are chemical behind this. So it's called capsaicin, and this is a compound that makes chili hot. Yeah, someone's already got it in chat. And what they do is activate nociceptors. So nociceptors are those pain receptors. And I think this used to be really popular. I think it's making a comeback. And I used to see like a bunch of I actually tried to do this once, because I saw a bunch of people on Snapchat trying to do that, and they were like crying in tears when they tried this angry looking chicken ramen. And then I tried the cheese one because the chicken looked more calm, and it said I think it had like half the Scovilles. So I'm like, okay, this is training wheels. But when I tried that one, the cheese is a lie. It does not help whatsoever. So then the thing is that it felt like a bunch of needles were going in my tongue. I just felt tasted nothing but pain. So yeah, spiciness this is why they don't consider it a basic taste. Instead of actually activating taste receptors, it's actually activating pain receptors. So this is why they don't classify it as a taste. It's also using pain relief. Now this is the interesting thing. Remember that concept about central adaptation? Well, this is kind of similar. Things that if you overwhelm a neuron or a receptor bombard it with signals, it needs time to recover. And we didn't get to cover refractory periods and negative feedback in terms of neuronal impulses, but Thing is that if you kind of overwhelm a receptor, then it doesn't really transmit the signal as much, and it's not really sensed as much by your brain. So the idea behind this is that if you overwhelm your pain receptors with capsaicin, then that kind of takes away the pain, because if you have the pain, but now you're just overwhelming and triggering those receptors and overwhelming them so that they no longer can fire those or be detected by your central nervous system. So yeah, capsaicin, the slow plus hot works that way. And why does our nose run when we eat spicy food? Ooh, actually that's a really good one, but we won't have time for that. I think someone should do their last fact question on that. Hint, hint. Yeah, so spiciness and nose run, because the thing is that it does lead to it is linked to thermoreceptors. I'll give you that hint. Alright, so then spiciness, and what we have here, so we have wasabi, and most of us are used to like wasabi as like a green paste we see at like Genki Sushi or in a little packet. But the kimchi hot is not the same as wasabi hot. And wasabi hot is actually due to a different compound, and this one is a long-term, a little organic chemistry, allyl isothiocyanate, but it's a different type of compound. And this is why whenever you eat too much, say you had like too much in your soy sauce, and if you've eaten the wasabi peas, eat too much at once, that's why it kind of feels like you're burning a hole in your head. So it also activates these pain receptors. Again, different, and it was also used for pain relief. I think this is like an old picture. I had a hard time finding this in stores. Maybe it fell out of fashion. But same sort of concept. If you overwhelm these pain receptors, it could cause pain relief. And the other interesting thing is that these open these ion channels so they are kind of similar in terms of like the overall, well, I don't want to confuse it with the taste, but the thing is that spicy is not the same as a taste, because they say it's linked more to the sense of pain than it is to the actual sense of taste on your tongue. Alright, so why does this happen? So this is due to opening these ligand-gated ion channel proteins in your membranes of these nociceptors. Now TRPV1 is a specific membrane protein that we're talking about. It's a gene for that protein. Now capsaicin activates these ion-gated or ligand-gated ion channels. So it's funny, like this. If you've eaten enough spicy food, you know what happens. Like maybe later on that evening or the day after. So you do find these nociceptors with TRPV1 in the tongue, but you also find these nociceptors in the gut and the colon and rectum. And it's kind of funny. Someone mentioned like how these plants evolved to make it painful to eat them, but humans eat it anyway. And not to get too specific, but the thing is that birds, they don't actually have this receptor. They are not able to detect the sense of spicy. So this is why if you've lived here long enough, like the Hawaiian chili peppers, like the one that's growing in my parents' backyard right now, it wasn't planted by us, it was planted by birds. Like birds, they love chili peppers because they only taste the sweet fruit part. They don't actually taste the spicy part because they don't have the receptors. No receptors for capsaicin, then they're not going to get that burn effect. So this comic is very cute, but if you want to be like one of those people who like to ruin everything like me, then you say like, oh, but birds don't have the receptors. But I like this receptor. I like it anyway because it shows this is why you get the afterburn after you eat a spicy meal.